Symbian is an open-source mobile operating system and computing platform designed for smartphones and currently maintained by Accenture. Symbian was originally developed by Symbian Ltd, as a descendant of Psion's EPOC and runs exclusively on ARM processors, although an unreleased x86 port existed. The current form of Symbian is an open-source platform developed by Symbian Foundation in 2009, as the successor of the original Symbian OS. Symbian was used by many major mobile phone brands, like Samsung, Motorola, Sony Ericsson, and above all by Nokia. It was the most popular smartphone OS on a worldwide average until the end of 2010, when it was overtaken by Android. Symbian rose to fame from its use with the S60 platform built by Nokia, first released in 2002 and powering most Nokia smartphones. UIQ, another Symbian platform, ran in parallel, but these two platforms were not compatible with each other. Symbian 3 was officially released in Q4 2010 as the successor of S60 and UIQ, first used in the Nokia N8, to use a single platform for the OS. In May 2011 an update, Symbian Anna, was officially announced, followed by Nokia Belle in August 2011. On February 11, 2011, Nokia announced that it would use Microsoft's Windows Phone OS as its primary smartphone platform, and Symbian will be its franchise platform, dropping Symbian as its main smartphone OS of choice. On June 22, 2011 Nokia made an agreement with Accenture for an outsourcing program. Accenture will provide Symbian-based software development and support services to Nokia through 2016. About 2,800 Nokia employees became Accenture employees as of October 2011. The transfer was completed on September 30, 2011. The Nokia 808 PureView is officially the last Symbian smartphone. History. Symbian originated from EPOC, an operating system created by Psion in the 1980s. In June 1998, Psion Software became Symbian Ltd, a major joint venture between Psion and phone manufacturers Ericsson, Motorola, and Nokia. Afterwards, different software platforms were created for Symbian, backed by different groups of mobile phone manufacturers. They include S60, UIQ and MOAP/S. In June 2008, Nokia announced the acquisition of Symbian Ltd, and a new independent non-profit organization called the Symbian Foundation was established. Symbian OS and its associated user interfaces S60, UIQ and MOAP/S, were contributed by their owners Nokia, NTT Docomo, Sony Ericsson and Symbian Ltd, to the foundation with the objective of creating the Symbian platform as a royalty-free, open-source software, under the OSI and FSF-approved Eclipse public license. The platform has been designated as the successor to Symbian OS, following the official launch of the Symbian Foundation in April 2009. The Symbian platform was officially made available as open-source code in February 2010. Nokia became the major contributor to Symbian's code, since it then possessed the development resources for both the Symbian OS core and the user interface. Since then Nokia has been maintaining its own code repository for the platform development, regularly releasing its development to the public repository. Symbian was intended to be developed by a community led by the Symbian Foundation, which was first announced in June 2008 and which officially launched in April 2009. Its objective was to publish the source code for the entire Symbian platform under the OSI and FSF-approved Eclipse public license. The code was published under EPL on February 4, 2010. Symbian Foundation reported this event to be the largest code base moved to open source in history. However, some important components within Symbian OS were licensed from third parties, which prevented the Foundation from publishing the full source under EPL immediately. Instead, much of the source was published under a more restrictive Symbian Foundation license and access to the full source code was limited to member companies only, although membership was open to any organization. In November 2010, the Symbian Foundation announced that due to changes in global economic and market conditions, it would transition to a licensing-only organization. Nokia announced it would take over the stewardship of the Symbian platform. Symbian Foundation will remain the trademark holder and licensing entity and will only have non-executive directors involved. On February 11, 2011, Nokia announced a partnership with Microsoft that would see it adopt Windows Phone as its primary smartphone platform, and Symbian will be its franchise platform. As a consequence, the use of the Symbian platform for building mobile applications dropped rapidly. Research in June 2011 indicated that over 39% of mobile developers using Symbian at the time of publication were planning to abandon the platform. By April 5, 2011, Nokia ceased to openly source any portion of the Symbian software and reduced its collaboration to a small group of pre-selected partners in Japan. Source code released under the EPL remains available in third-party repositories. On June 22, 2011, Nokia made an agreement with Accenture for an outsourcing program. Accenture will provide Symbian-based software development and support services to Nokia through 2016. About 2,800 Nokia employees became Accenture employees as of October 2011. The transfer was completed on September 30, 2011. On January 1, 2014, with Nokia shifting their developer support away from Symbian, developers will not be able to publish new Symbian applications or content into the Nokia Store. However, existing Nokia Store content can still be downloaded. Features: User interface. Symbian has had a native graphics toolkit since its inception, known as AVKON. S60 was designed to be manipulated by a keyboard-like interface metaphor, such as the 15-key augmented telephone keypad, or the mini QWERTY keyboards. AVKON-based software is binary compatible with Symbian versions up to and including Symbian 3. Symbian 3 includes the Qt framework, which is now the recommended user interface toolkit for new applications. Qt can also be installed on older Symbian devices. Symbian 4 was planned to introduce a new GUI library framework specifically designed for a touch-based interface, known as UI Extensions for Mobile, or UIEMO, which was built on top of Qt Widget. A preview was released in January 2010, however in October 2010 Nokia announced that Orbit UIEMO had been cancelled. Nokia currently recommends that developers use Qt Quick with QML, the new high-level declarative UI and scripting framework for creating visually rich touchscreen interfaces that allows development for both Symbian and MeeGo. It will be delivered to existing Symbian 3 devices as a core update. When more applications gradually feature a user interface reworked in Qt, the legacy S60 framework will be deprecated and no longer included with new devices at some point, thus breaking binary compatibility with older S60 applications. Browser. Symbian 3 and earlier have a built-in WebKit-based browser. Symbian was the first mobile platform to make use of WebKit. Some older Symbian models have Opera Mobile as their default browser. Nokia released a new browser with the release of Symbian Anna with improved speed and an improved user interface. Multiple language support. Symbian has strong localization support enabling manufacturers and third-party application developers to localize their Symbian-based products in order to support global distribution. Current Symbian release has support for 48 languages, which Nokia makes available on device in language packs. All language packs have in common English. The supported languages, with dialects in Symbian Belle are, Symbian Belle marks the introduction of Kazakh, while Korean is no longer supported. Japanese is only available on Symbian 2 devices as they are made in Japan, and on other Symbian devices Japanese is still supported with limitations. Application development. From 2010, Symbian switched to using standard C++ with Qt as the main SDK, which can be used with either Qt Creator or Carbide C++. Qt supports the older Symbian S60 3rd and Symbian S60 5th edition releases, as well as the new Symbian platform. It also supports Memo and MeeGo, Windows, Linux and Mac OS X. Alternative application development can be done using Python, Adobe Flashlight or Java ME. Symbian OS previously used a Symbian-specific C++ version, along with Carbide C++ integrated development environment, as the native application development environment. Web Runtime is a portable application framework that allows creating widgets on the S60 platform. It is an extension to the S60 WebKit-based browser that allows launching multiple browser instances as separate JavaScript applications. Application Development, Qt. As of 2010, the SDK for Symbian is standard C++, using Qt. It can be used with either Qt Creator, or Carbide. A phone simulator allows testing of Qt apps. Apps compiled for the simulator are compiled to native code for the development platform, rather than having to be emulated. Application development can either use C++ or QML. Symbian C++, as Symbian OS is written in C++ using Symbian Software's coding standards, it is possible to develop using Symbian C++, although it is not a standard implementation. Before the release of the Qt SDK, this was the standard development environment. There were multiple platforms based on Symbian OS that provided software development kit for application developers wishing to target Symbian OS devices, the main ones being UIQ and S60. Individual phone products, or families, often had SDKs or SDK extensions downloadable from the maker's website too. The SDKs contain documentation, the header files and library files needed to build Symbian OS software, and a Windows-based emulator. Up until Symbian OS version 8, the SDKs also included a version of the GNU compiler collection compiler needed to build software to work on the device. Symbian OS 9 and the Symbian platform use a new application binary interface and needed a different compiler. A choice of compilers is available including a newer version of GCC. Unfortunately, Symbian C++ programming has a steep learning curve, as Symbian C++ requires the use of special techniques such as descriptors, active objects and the cleanup stack. This can make even relatively simple programs initially harder to implement than in other environments. It is possible that the techniques, developed for the much more restricted mobile hardware and compilers of the 1990s, caused extra complexity in source code because programmers are required to concentrate on low-level details instead of more application-specific features. As of 2010, these issues are no longer the case when using standard C++, with the Qt SDK. Symbian C++ programming is commonly done with an integrated development environment. For earlier versions of Symbian OS, the commercial IDE CodeWarrior for Symbian OS was favored. The CodeWarrior tools were replaced during 2006 by Carbide C++, an Eclipse-based IDE developed by Nokia. Carbide C++ is offered in 4 different versions: Express, Developer, Professional, and OEM, with increasing levels of capability. Fully featured software can be created and released with the Express edition, which is free. Features such as UI design, crash debugging etc. are available in the other, charged-for, editions. Microsoft Visual Studio 2003 and 2005 are also supported via the Carbide vs plugin. Other languages. Symbian devices can also be programmed using Python, Java ME, Flashlight, Ruby, .NET, Web Runtime widgets and standard C++. Visual Basic's programmers can use NS Basic to develop apps for S60 3rd edition and UIQ3 devices. In the past, Visual Basic, Visual Basic.NET, and C development for Symbian were possible through AppForge Crossfire, a plugin for Microsoft Visual Studio. On March 13, 2007, AppForge ceased operations. Oracle purchased the intellectual property, but announced that they did not plan to sell or provide support for former AppForge products. Net60, a .NET Compact framework for Symbian, which is developed by Redviver Labs, is sold as a commercial product. With Net60, VB.NET and C source code is compiled into an intermediate language which is executed within the Symbian OS using a just-in-time compiler. There is also a version of a Boolean IDE for Symbian OS. Symbian OS development is also possible on Linux and Mac OS X using tools and methods developed by the community, partly enabled by Symbian releasing the source code for key tools. a plugin that allows development of Symbian OS applications in Apple's Xcode IDE for Mac OS X was available. Java ME applications for Symbian OS are developed using standard techniques and tools such as the Sun Java Wireless Toolkit. They are packaged as jar files. Both CLDC and CDC applications can be created with NetBeans. Other tools include SuperWaba, which can be used to build Symbian 7.0 and 7.0's programs using Java. Nokia S60 phones can also run Python scripts when the interpreter Python for S60 is installed, with a custom-made API that allows for Bluetooth support and such. There is also an interactive console to allow the user to write Python scripts directly from the phone. Deployment. Once developed, Symbian applications need to find a route to customers' mobile phones. They are packaged in SIS files which may be installed over the air, via PC Connect, Bluetooth or on a memory card. An alternative is to partner with a phone manufacturer and have the software included on the phone itself. Applications must be Symbian signed for Symbian OS 9X in order to make use of certain capabilities. Applications can now be signed for free. Architecture, technology domains and packages. Symbian's design is subdivided into technology domains, each of which comprises a number of software packages. Each technology domain has its own roadmap, and the Symbian Foundation has a team of technology managers who manage these technology domain roadmaps. Every package is allocated to exactly one technology domain, based on the general functional area to which the package contributes and by which it may be influenced. By grouping related packages by themes, the Symbian Foundation hopes to encourage a strong community to form around them and to generate discussion and review. The Symbian system model illustrates the scope of each of the technology domains across the platform packages. Packages are owned and maintained by a package owner, a named individual from an organization member of the Symbian Foundation, who accepts code contributions from the wider Symbian community and is responsible for package. Symbian Kernel. The Symbian kernel supports sufficiently fast real-time response to build a single-core phone around ETA that is, a phone in which a single processor core executes both the user applications and the signaling stack. The real-time kernel has a microkernel architecture containing only the minimum, most basic primitives and functionality, for maximum robustness, availability and responsiveness. It has been termed a nanokernel, because it needs an extended kernel to implement any other abstractions. It contains a scheduler, memory management and device drivers, with networking, telephony and file system support services in the OS services layer or the base services layer. The inclusion of device drivers means the kernel is not a true microkernel. Design. Symbian features preemptive multitasking and memory protection, like other operating systems. EPOC's approach to multitasking was inspired by VMS and is based on asynchronous server-based events. Symbian OS was created with three systems design principles in mind: the integrity and security of user data is paramount, user time must not be wasted, all resources are scarce. To best follow these principles, Symbian uses a microkernel, has a request and callback approach to services, and maintains separation between user interface and engine. The OS is optimized for low-power battery-based devices and for RAM-based systems. Applications, and the OS itself, follow an object-oriented design, model view controller. Later OS iterations diluted this approach in response to market demands, notably with the introduction of a real-time kernel and a platform security model in versions 8 and 9. There is a strong emphasis on conserving resources which is exemplified by Symbian-specific programming idioms like descriptors and a cleanup stack. Similar methods exist to conserve storage space. Further, all Symbian programming is event-based, and the central processing unit is switched into a low-power mode when applications are not directly dealing with an event. This is done via a programming idiom called active objects. Similarly, the Symbian approach to threads and processes is driven by reducing overheads. Operating system. The all-over model contains the following layers, from top to bottom: UI framework layer, application services layer, Java ME. OS services layer, generic OS services, communications services, multimedia and graphics services, connectivity services. Base services layer, kernel services and hardware interface layer. The base services layer is the lowest level reachable by user-side operations. It includes the file server and user library, a plugin framework which manages all plugins, store, central repository, DBMS and cryptographic services. It also includes the text window server and the text shell, the two basic services from which a completely functional port can be created without the need for any higher layer services. Symbian has a microkernel architecture, which means that the minimum necessary is within the kernel to maximize robustness, availability and responsiveness. It contains a scheduler, memory management and device drivers, but other services like networking, telephony and file system support are placed in the OS services layer or the base services layer. The inclusion of device drivers means the kernel is not a true microkernel. The EK82 real-time kernel, which has been termed a nanokernel, contains only the most basic primitives and requires an extended kernel to implement any other abstractions. Symbian is designed to emphasize compatibility with other devices, especially removable media file systems. Early development of EPOC led to adopting FAT as the internal file system, and this remains, but an object-oriented persistence model was placed over the underlying FAT to provide a POSIX-style interface and a streaming model. The internal data formats rely on using the same APIs that create the data to run all file manipulations. This has resulted in data dependence and associated difficulties with changes and data migration. There is a large networking and communication subsystem, which has three main servers called ETL, ESOCK and C32. Each of these has a plugin scheme. For example, ESOCK allows different PRT protocol modules to implement various networking protocol schemes. The subsystem also contains code that supports short-range communication links, such as Bluetooth, IRDAR and USB. There is also a large volume of user interface code. Only the base classes and substructure were contained in Symbian OS, while most of the actual user interfaces were maintained by third parties. This is no longer the case. The three major UIs are S60, UIQ and MOAP were contributed to Symbian in 2009. Symbian also contains graphics, text layout and font rendering libraries. All native Symbian C++ applications are built up from three framework classes defined by the application architecture: an application class, a document class and an application user interface class. These classes create the fundamental application behavior. The remaining needed functions, the application view, data model and data interface, are created independently and interact solely through their APIs with the other classes. Many other things do not yet fit into this model for example, SyncML, Java ME providing another set of APIs on top of most of the OS and multimedia. Many of these are frameworks, and vendors are expected to supply plugins to these frameworks from third parties. This has the advantage that the APIs to such areas of functionality are the same on many phone models, and that vendors get a lot of flexibility. But it means that phone vendors needed to do a great deal of integration work to make a Symbian OS phone. Symbian includes a reference user interface called TechView. It provides a basis for starting customization and is the environment in which much Symbian test and example code runs. It is very similar to the user interface from the Psion Series 5 personal organizer and is not used for any production phone user interface. Symbian UI variations and platforms. Symbian, as it advanced to OS version 7.0, began to spun off into several different user interfaces or UIs, each backed by a certain company or group of companies. Unlike Android OS with its different cosmetic UIs, Symbian UIs are deeper in code modifications and integrations. Things began more complicated when applications developed for different Symbian UIs platforms are not compatible with each other, and this led to OS fragmentation. User interfaces platforms that run on or are based on Symbian OS include S60, Symbian, also called Series 60. It was backed mainly by Nokia. There are several editions of this platform, appearing first as S60 on Nokia 7650. It was followed by S60 second edition and touch-based S60 fifth edition. The name, S60, was dropped after the formation of Symbian Foundation and renames itself as Symbian 1, 2 and 3. Series 80, used by Nokia communicators such as Nokia 9300i. Series 90, touching button-based. Only phone using this platform is Nokia 7710. UIQ, backed mainly by Sony Ericsson and then Motorola, it is compatible with both buttons and touch stylus-based inputs. The last major release version is UIQ 3.1 in 2008, on Sony Ericsson G900. It was discontinued after the formation of Symbian Foundation, and the decision to consolidate different Symbian UI versions into one led to the adoption of S60 as the version going forward. MOAP, Japan only, used by Fujitsu, Mitsubishi, Sony Ericsson and Sharp developed phones for NTT Docomo. It uses an interface developed specifically for Docomo's FOMA Freedom of Mobile Access Network brand and is based on the UI from earlier Fujitsu FOMA models. The user cannot install new C++ applications. OPP, Japan only, successor of MOAP, used on NTT Docomo's FOMA phone. Symbian version comparison. Manufactured by Fujitsu, a Euro manufactured by Sharp. Market share and competition. On November 16, 2006, the 100 millionth smartphone running the OS was shipped. As of July 21, 2009, more than 250 million devices running Symbian OS had been shipped. In 2006, Symbian had 73% of the smartphone market, compared with 22.1% of the market in the second quarter of 2011. Symbian has lost market share over the years as the market has dramatically grown, with new competing platforms entering the market, though its sales have increased during the same time frame. For example, although Symbian's share of the global smartphone market dropped from 52.4% in 2008 to 47.2% in 2009, shipments of Symbian devices grew 4.8%, from 74.9 million units to 78.5 million units. From Q2 2009 to Q2 2010, shipments of Symbian devices grew 41.5%, by 8.0 million units, from 19,178,910 units to 27,129,340. Compared to an increase of 9.6 million units for Android, 3.3 million units for RIM, and 3.2 million units for Apple. Prior reports on device shipments as published in February 2010 showed that the Symbian devices formed a 47.2% share of the smart mobile devices shipped in 2009, with RIM having 20.8%, Apple having 15.1%, Microsoft having 8.8% and Android having 4.7%. In the number of smart mobile device sales, Symbian devices were the market leaders for 2010. Statistics showed that Symbian devices formed a 37.6% share of smart mobile devices sold, with Android having 22.7%, RIM having 16%, and Apple having 15.7%. Some estimates indicate that the number of mobile devices shipped with the Symbian OS up to the end of Q2 2010 is 385 million. Over the course of 2009 Euro 2010, Motorola, Samsung, LG, and Sony Ericsson announced their withdrawal from Symbian in favor of alternative platforms including Google's Android, Microsoft's Windows Phone. In Q2 2012 according to IDC worldwide market share has dropped to an all-time low of 4.4%. Criticism: the users of Symbian in the countries with non-Latin alphabets have been criticizing the complicated method of language switching for many years. For example, if a user wants to type a Latin letter, he must call the menu, click the languages item, use arrow keys to choose, for example, the English language from among many other languages, and then press the OK button. After typing the Latin letter, the user must repeat the procedure to return to his native keyboard. This method slows down typing significantly. In touch phones and QWERTY phones the procedure is slightly different but remains time-consuming. All other mobile operating systems, as well as Nokia's S40 phones, enable switching between two initially selected languages by one click or a single gesture. Early versions of the firmware for the original Nokia N97, running on Symbian 1/Series 65th edition, have been heavily criticized as buggy. In November 2010, smartphone blog All About Symbian criticized the performance of Symbian's default web browser and recommended the alternative browser Opera Mobile. Nokia's senior vice president Joe Harlow promised an updated browser in the first quarter of 2011. There are many different versions and editions of Symbian, which led to fragmentation. Apps and software may be incompatible when installed across different versions of Symbian. Malware. Symbian OS is subject to a variety of viruses, the best known of which is KBear. Usually these send themselves from phone to phone by Bluetooth. So far, none have taken advantage of any flaws in Symbian OS. Instead, they have all asked the user whether they would like to install the software, with somewhat prominent warnings that it can't be trusted, although some rely on social engineering, often in the form of messages that come with the malware, purporting to be a utility, game or some other application for Symbian. However, with a view that the average mobile phone user shouldn't have to worry about security, Symbian OS 9X adopted a Unix-style capability model. Installed software is theoretically unable to do damaging things without being digitally signed, thus making it traceable. Commercial developers who can afford the cost can apply to have their software signed via the Symbian Sign program. Developers also have the option of self-signing their programs. However, the set of available features does not include access to Bluetooth, IRDAR, GSM cellular, voice calls, GPS and few others. Some operators have opted to disable all certificates other than the Symbian signed certificates. Some other hostile programs are listed below, but all of them still require the input of the user to run. Drevere is a malicious SIS file Trojan that attempts to disable the automatic startup from Symworks and Kaspersky Symbian antivirus applications. LockNAB is a malicious SIS file Trojan that pretends to be a patch for Symbian S60 mobile phones. When installed, it drops a binary that will crash a critical system service component. This will prevent any application from being launched in the phone. Mabire is basically KBear with added MMS functionality. The two are written by the same author, and the code shares many similarities. It spreads using Bluetooth via the same routine as early variants of KBear. As Mabire activates, it will search for the first phone it finds, and start sending copies of itself to that phone. Fontle is an SIS file Trojan that installs a corrupted file which causes the phone to fail at reboot. If the user tries to reboot the infected phone, it will be permanently stuck on the reboot, and cannot be used without disinfection. That is, the use of the reformat key combination which causes the phone to lose all data. Being a Trojan, Fontle cannot spread by itself. The most likely way for the user to get infected would be to acquire the file from untrusted sources, and then install it to the phone, inadvertently or otherwise. A new form of malware threat to Symbian OS in the form of cooked firmware was demonstrated at the International Malware Conference, MalCon, December 2010, by Indian hacker Dialects. Bypassing platform security, Symbian OS 9X devices can be hacked to remove the platform security introduced in OS 9.1 onwards, allowing users to execute unsigned code. This allows altering system files, and access to previously locked areas of the OS. The hack was criticized by Nokia for potentially increasing the threat posed by mobile viruses as unsigned code can be executed. Version history, see also, General, Android, BARDA, EKA2 current Symbian kernel, successor of EKA1, EPOC, list of Symbian devices, MOAP user interface, Nokia OV Suite, Series 60 remote, Nokia PC Suite, software package used to establish an interface between Nokia mobile devices and computers running Microsoft Windows operating system. Not limited to Symbian, Nokia Software Updater, S60, Series 60, user interface used by Nokia and others, Web browser for S60 default web browser. OV Store Nokia's application store on the Internet, not limited to Symbian, Symbian Foundation, Symbian Ltd. Development related, accredited Symbian developer, Active Object, Carbide C++, Alternative Application and OS Development IDE, Cleanup Stack, PIPS is POSIX on Symbian, Python for S60, Alternative Application Development Language, Qt, Preferred Development Tool, both for the OS and applications, not limited to Symbian, Qt Creator IDE, Qt Quick, QML, JavaScript-based language. Applications, C category, Symbian software, references. Bibliography. External links, Symbian Foundation blog, Symbian on Olo, Symbian at DMOZ, Qt developer website, Symbian C++ developer website, Symbian 3 EPL source, most complete Symbian open source archive, Symbian dump, a full dump of all the public source code from the Symbian project under the original Eclipse public license, as of 07-2010, WildDux, BeagleBoard port of Symbian S3, Symaptic, CMake build systems Symbian Mercurial repository.